We are starting chapter 7, and in this chapter we will be focusing on factoring, which is a really important topic because it's used in many math classes to come. So in this section 7.1 we will focus on greatest common factor and also factoring by grouping. We can use abbreviation GCF for greatest common factor. I have already worked out examples 1, 2, and 3, so we'll go over those and then do the rest together. So for example 1, okay, what we want to do, directions say to factor completely. Example 1, we have a binomial, 14x plus 21. And what we want to do is factor out the greatest common factor. Greatest common factor, if you remember, is the largest number that divides, in this case, both terms. So the largest number that goes into 14 and 21, that's 7. So I have that written on the side here. And then in order to factor, what we want to do is you're going to take the 7 and then put it on the outside, and then we have these two parentheses. And on the inside you write what you get once you factor out 7. So that would be 2x plus 3. And then you check your answer by distributive property. 7 times 2, that's 14. 7 times 3, that's 21. And then we have example 2. So what we're doing is we're looking at these two terms. Maybe if I do this, it'll help. All right, so we're looking at 4x minus 8y. So first of all, notice that you have the 4 and the 8, and we also notice that there's an a in both terms. In terms of the variable, whatever is common to all terms will be included in the GCF. Since both terms have an a, we have to include a in the GCF. So our GCF will be 4a. 4 goes into 4, 4 goes into 8, and then a is common to both. So GCF is 4a. You write that on the outside, parentheses, and then once we factor out 4a, what's left? X minus 2y. So remember, the a gets factored out, so then you were just left with x minus 2y. Use the distributive property and check your answer, and we get back to the original. Example 3. Imagine you didn't see the answer, but example 3, this is a trinomial. So we're looking at 8, 32, and 8. The largest number that divides all three would be 8. Okay, so GCF is 8. What about the y? Y squared, y, and this has no y. We don't include a y in the GCF here because it's not common to all three. It has to be common to all three. So 8 doesn't have a y, so we don't include the y. So GCF is just 8. That goes on the outside, and then we're left with just y squared minus 4y plus 1. This is important here. This 1, you have to put it there because when you check your work, you have to get back to the original. 8 times y squared, 8 times negative 4y, 8 times 1. You have to put a 1 because then we get back to this. Sometimes people forget and they just think the answer is y squared minus 4y, and they don't put a 1. However, if you leave it like this, you won't get back to the original. So be careful with the 1. Example 4. All right, this one a little bit more complicated because we have two variables, x and y. So the first thing is figure out what the GCF is. So let's see. Let's start with the numbers. 36, 45, and 24. What number, okay, largest number, divides all three of them? It looks like it would be 3. Now, how do I deal with these variables? Notice that all three terms have x and y, but they have different exponents. So remember, whatever you write for your GCF has to be common to all three. So in terms of variables, what you do is just look at, like for example, look, this has y squared, y squared, y squared. Y squared is common to both, so I can, to all three of them, I can include that. X to the fourth, x cubed, x squared. All three have at least x squared. All three of them have at least two x's, so we include x squared. So if you have different exponents, just pick the smallest exponent for your GCF because that would be common to all three. Let's write what we get when we factor. You write your GCF on the outside, parentheses. So then 3 goes into 36 12 times. This y squared is factored out, so then we also took out x squared, so we're left with just x squared on the inside. Remember, when I multiply these two, I have to get back to 36 y squared x to the fourth. In terms of x squared times x squared, the rule is that you add the exponent. So 2 plus 2 has to get me back to 4, which it does. Okay, so you can always check by adding the exponents. Minus 3 goes into 45 how many times? 3 goes into 45 15 times. And then x squared, so I need to have an x here because 2 plus 1 gets me back to 3. Plus 8, and then that's it. No variable here because when I multiply, I get back to y squared x squared. So this is my final answer. This one's a little bit more complicated only because you have to be careful with the exponents. So just make sure you just practice these. You have problems like this in your book, so take a look at them and try them out yourself and check your answers. Okay, we have one more problem like number 4, which is right here, number 5. So we have a trinomial, and this is an interesting problem because you can actually factor out a negative GCF. Okay, why? Because all three terms here have a negative, so we could factor out a negative GCF. So what would the GCF be? I've got -3, -6, -9. Numbers are pretty small, so you should see that -3 is the GCF. What about the variables? X squared, x cubed, x squared. You pick the smallest exponent, x squared. Y to the fourth, y to the fourth, y to the third. Smallest, so that's what I use. Okay, that's my GCF. Write that on the outside. Parentheses. And then what's left? So when I factor out a -3 x squared y cubed, for the first term, we're just left with y to the first. Okay? Now, since I factored out a negative GCF, the signs change. This becomes plus 2x y. Because if I take the GCF, multiply it with 2xy, you have to get -6x cubed y to the fourth, which I do, so I know it's correct. Plus 3, and that's it. Close the parentheses. -3 times 3, that's -9, and I get x squared y cubed. So that's our final answer. Okay, so notice, one thing to notice here. Problems 1 through 5, the GCF is one term. Okay, so our GCF so far has been a monomial, one term. Well, the GCF can also be a binomial. Doesn't have to be one term. The GCF can be two terms. For example, number 6. This is a little different. This problem contains these parentheses. So you basically have part 1 and part 2. Notice that a minus 7 is common to both the first and the second part. So since it's common to both of these, I can think of a minus 7 as the GCF. This is two terms. It's a binomial. That's okay. You do the same thing. You find what's common to both, which is a minus 7. I write that on the outside, and then I write parentheses, and I write what's left. But this is a binomial, so I have to put this binomial in parentheses. All right, so when I factor, I take out a minus 7, factor that out, so this comes out in front. And what are we left with? You're left with 6a minus 5. That goes in the second parentheses right here. This is our final answer. Sometimes these are a little bit easier than the previous problems. Okay, so this is completely factored and we're done. And if you want to check your work, just take the whole binomial, multiply it with 6a, and you get part 1. Take this whole binomial, multiply it with negative 5, and I get part 2, so I know it's correct. Number 7, same type of problem. Look, x minus 10, x minus 10. That's your GCF. It is common to both part 1 and part 2. So what do? Factor it out in parentheses because it's a binomial. Take out x minus 10, what's left? 3a and 5b with a plus because there's a plus there. And then we're done. So 6 and 7 a little bit faster than the ones that we have previously done. Okay, last 3 examples. These 3 examples are slightly different. These 3 examples contain 4 terms. And in order to factor them, we are going to use factor by grouping, part 2 of this section. Okay, so what we want to do here, we have 4 terms, and we want to factor by grouping. So when you take your test, it will not say factor by grouping. You just need to know that you factor by grouping. So look to see if you have 4 terms. That is a clue that you probably have to factor by grouping. Not all the time, but for the most part. Factoring by grouping is actually pretty straightforward. What you do is make sure you have 4 terms, which we do. What you do is you're going to group, like the name says. We're going to kind of group the first 2 and the last 2 terms. And we factor out the GCF separately. GCF from the first 2, GCF from the last 2. GCF for the first 2 terms is 3. Okay, 3 times what? 3 times x plus y. Part 1 is done. GCF from the second part is going to be a because that's common to both. The sign comes down, plus plus. Take out the a or factor out the a. You get x plus y. Does that look familiar? Yes, because we just did that in the previous example. From this step, we follow what we just did. X plus y is common to both. That's the GCF. Factor it out. This is the last step. What's left? 3 plus a. Factoring is done. Example 9 and 10 will work the same way. So example 9, let's see. We will look at the first 2, look at the last 2. Okay, you just want to underline them. Do not put these in parentheses yet. Just underline. So GCF for the first 2 terms is x. You factor it out. What's left? 1 minus 3y. Okay? plus, we could factor out a 2z. What's left? 1 minus 3y. Make sure that what you have in the parentheses and the GCF on the outside gives you what you started with. You check your work. Okay, notice you have the same binomial. That's what you want when you factor by grouping. Same binomial, same binomial. If it asks us to factor by grouping and we do not have the same binomial, then we either made a mistake or something's wrong with the problem. So let's see, since I have the same binomial, that gets factored out. What's left? X plus 2z, and we are done. All right, last example. We have 4 terms. I didn't have enough space, so I've got this plus 30uv off to the side. Hope that's clear. Just follow the same process. Group the first 2 terms, and then we group the last 2. Okay, so this is xy plus 5yv plus 6xu plus 30uv. First 2 terms, GCF is y. Then in the parentheses, x plus 5v. Okay? Plus, bring down the sign. Second 2 terms, you're going to factor out the GCF. So I know it's written like a weird way here, but we've got you've got 6 and you've got 30. So the GCF is going to be 6u. And then we're left with x plus 5v. When you check your work, again, please check your work, you get back to the original. Okay, these 2 binomials are exactly the same, so I know that this is correct. And you have your last step. And that's our final answer.